Hey there. Ah, all right, so we left off with 17 macros. So let's see what's going on here. It looks like exclamation mark means macro. We've already encountered that with print and write and those other things, which presumably we were told right at the very beginning were macros. So here we are. We get a powerful macro system that allows meta programming. Used to be known as, just like defines and includes, whatever. As you've seen in previous chapters, macros look like functions, except their names end with a bang, but instead of generating a function call, macros expand in the source code. So that makes sense. So unlike C macros in other languages, Rust macros are expanded into abstract syntax trees rather than string preprocessing, so you don't get unexpected precedence bugs. Well, that's interesting. Because in C, if you had a macro, you'd drop in it, or PHP, for example, you do an include of the file. It just takes the contents of the file and just plunks them right there, and then it processes it as if those two files were in fact one file. This is saying they're doing something different. Cool. Okay, so macro rules say hello, indicates the macro takes no argument, bracket, bracket, arrow, the fat arrow syntax, because, let's borrow some other stuff. So this is the same syntax that JavaScript and C# use for defining nameless functions, nameless functions is to do this kind of thing. But in fact, this has a name, but then the internals, whatever. All right, so we just end up with an extra set of brackets, and inside we go, we don't take any parameters. Say hello. Cool. Don't repeat yourself. So this one, don't repeat yourself. Really, if you don't want to repeat yourself, you could create a function. So that really doesn't give me a reason to write a macro instead of a function. Domain-specific language. Macros allow you to define special syntax for a specific purpose. Okay. Variadic interfaces. Sometimes you want to define an interface that takes a variable number of arguments. Okay. All right. So there's... All right. So this one is the first one where I kind of go, okay. Because if you can call these things as if they were functions, then writing a function and doing this are effectively the same thing, I would think. But this one, if you can't do that with a normal function, which apparently we can't because back in section 9 there was functions and they never talked about this. So this may be kind of the one thing that I would go, oh, okay, that's cool. That is a reason to do a macro. And that's probably why println is implemented and write is implemented as a macro rather than a function, because you can do this third thing. The other stuff, whatever. Just filling out a list. Okay, syntax. Patterns, overloading, repetition. Okay, let's see. The arguments of a macro are prefixed by a $sign and type annotated with a designator. Okay, where's the $sign? Macro rules create function. $func name ident. Okay. And there's the fat arrow. Curly braces, func. Oh, this is interesting. Func name. So let's go back one page. What? Back 2 pages. So let me see. How many brackets do we have here? We had bracket after the say hello. We had brackets after the fat arrow. And that was it. Now this one has brackets out here after the name, brackets after the round brackets, to there. That one goes to there. That one goes to there. And then inside there we have a function, func name, which also has its own curly bracket. So this level here is new. But this, oh, I see. This is returning a function. Well, that's kind of fun. Okay. All right, so we're going to create a function called funcName that's going to do some work. Interesting. Okay, cool. Cool. I guess I should read the comments. Creates a function named funcName. All right, that's why the extra set of brackets. All right, sure. Okay, correct functions foo and bar with the above macro. Yep. Okay, macro rules print result. So here, there's the one set of curly brackets that goes there, and we do the print. So stringify will convert the expression as it is into a string. So print result, stringify expression, the parameter is expression, and then, oh, okay, stringify expression equals expression. Expression. Oh, is it going to execute the expression? Interesting. Okay. Foo and bar, print result that, recall that blocks or expressions to, print result, blah, 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 blah. Okay, so let's run this, because I'm curious to see what will happen. Oh, right, down here. You called foo, double quotes, you called stringify function name. You called where did no, you called that. So those double the double quotes here, these double quotes are because stringify is turning the function name into a string, including the quotes. Interesting. You called bar, whatever. And then this, so we're passing in this expression, and it's going to put stringify it, which means it's going to take the expression and, yeah, and it did. This executed the expression. 2. 1 plus 1 equals 2. And then this blocks our expressions too. So let x equals blah, 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 blah. They're going to return that. So this is x times x plus 2 times x, where x is 1. So 1 times 1 is 1, plus 2 times 1 is 2, which is 3, minus 1 is 2. Okay, cool. All right. Fun. The curly brackets are there too, which means that it's taking these curly brackets and making them part of the thing. Oh, that's cool. Okay. So that means, interesting. Is there an opposite to stringify? Can you convert a string into an expression? That would be dangerous, don't you think? I mean, this is the whole thing with this, like, user input that we then have to do, you know, SQL injection attack defense and stuff like that, because the string is the thing to execute. Yeah, do the same thing in JavaScript too, if you're not careful. So I betcha they don't do that, because that just seems like a dangerous thing to do. Well, you never know. All right, so that's cool. All right, macros can be overloaded. Oh, wait a minute. Before I do that, back one thing. So I just want to notice this ident, a designator, is used for variable function names. So variable identity, okay, sure. And then expr is for expressions. So are those the only two unique ones? of the designators. Oh, right. And I just kind of skipped over this. Block, expression, ident, we use those two. Item, no explanation. Block, no explanation. Literal, okay. Pattern. You're not telling me a whole lot here. All right, so for a complete list, see the Rust reference. All right, let's put that away. Let's open this in a new tab. And let's see. Maybe we've got some more explanation. Block, exper, ident, item, lifetime, literal, meta, pat, param, path, statement, tt, ty, viz. Ugh, none of this tells me anything. Okay, transcribing, forwarding, meta variables. Oh, here we are. Okay. An item. Still didn't tell me what an item is, but at least I get a link. Item. Oh, okay. So, module, external, user, function, type alias, struct, trait. Basically, what? Item is a viz item or a macro item. A viz item is one of these things or a macro. Okay, an item is the component of a crate. Items are organized within a crate by a nested set of modules. Every crate has an outermost anonymous module. Okay, so items are kind of the top level thing. Okay. Block. We know what a block is. We know what a statement is. Pattern. Let's see what that is. Pattern. Pattern without range. Range pattern. Alright. Patterns are used to match values against structures and to optionally bind variables to values inside these structures. Oh, okay. Tests if a person, the pattern in the following example does four things. Tests if a person has the car field filled in with something. Car sum. Let person. So this is a pattern. It looks like an object. Tests if a person's age is between 13 and 19. Binds a reference to the name for a person name. Okay, and then ignores the rest of the fields of person. Remaining fields can have any value not bound to these. Oh, okay. So it's like a validation. That's cool. Oh, I like that. Match expressions. Patterns can be used to destructure. Destructuring breaks up a value. Alright. Yep. Okay. Cool. That would come in handy. And so that's pat is the same thing. Expression we did. Type. I think we know what a type is. Ident we did. Path. A type path. Style path. That again tells me nothing. Paths in types. Is a type path. Is a type path segment. Type path segment. Path ident segment. Yeah, seriously. Okay, this awesome, but I'm not going to decipher. I'm not going to try to decipher that. That's too. Let's see if the English helps. Type paths are used within type definitions, trait bounds, and type parameter bounds and qualified paths. They're used there, but what are they? Although the is allowed before the generics arguments, not required. Holy mackerel. Okay. Oh, no. The path down to, so that, yeah, okay, that's the path. Okay. All right. All right. All right. All right. Okay. Interesting why you'd want to pass a path, but okay. Sure. Why not? A token tree. Oh, let's not even bother. Attribute. Lifetime token. Oh, right. We talked about lifetimes. We had the lifetime of an object, and it returned a lifetime, I think, if I remember correctly. So that's probably what that is. Visibility qualifier. Visibility of... Oh, is this like scope? Visibility pub. Oh, visibility and privacy. These two terms are often used interchangeably, and what they are attempting to convey is the answer, can this item be used at this location? Yeah, yeah. Yeah, that's the scope. And literal, we know what a literal is. Okay, cool. Yay. We kind of get the feeling. So, you need to be really, really deep into Rust for this to mean anything. Maybe we'll bump into it again sometime in the far distant future. Macros can be overloaded to accept different combinations of arguments. Macro rules test. And left expression and. Arguments don't need to be separated by a comma. Any template can be used. Each arm must end with a semicolon. What? Test will compare left and right in different ways depending on how you invoke it. Okay. And an or. So, arguments don't need to be separated by comma. Any template can be used. So I guess that's a template. But what's this and? Because I get it, it's an and. So you're saying, okay, I want something with the and then I want something else. Okay, let me just do this. Let me run this. Okay. That and that equals true. True or false equals true. What? How is... Oh, because it's evaluating the expression. But 2 times 2 is 4. Oh, that's true. Oh, I see. So it's it's doing the comparison. So it's 1 plus 1 is 2, but it's a double equals. So we're saying, okay, if that is the same as that, or if that's true and that's true, then this is true. And then this one, the right expression is false. Okay, so let's change this to be Fred and Barney. And if I change this to be Fred, or actually, let me leave it as and I'm going to run this and see what happens. Okay. It says no rules expect this token in the macro call. Nice. No, I'll try to match Fred. No rules expect. Okay. All right. So fair enough. Couldn't find Fred. Barney. Run that. Yeah, there it works. Oh, right, but it still says and or, because in the string here it's still and or. So, oops, move my fingers over. Well, there we go. Oh, little wife swapping going on here. Yep, there we go. Cool. All right, moving on. All right, macros use the plus in the argument list to indicate that an argument be repeated at least once, or star to indicate 0 or more times. The following example surrounds the matcher with will match one or more expressions separated by commas. Also note that the semicolon is optional in the last case. So this is how they do the print with the multiple parameters. Yeah. Find min, compare min, find min. Really? You're going to use recursion for this? Okay. Well, I suppose, I mean, everything's on the stack here, so it's not terrible. Just seems excessive to make a call. I wonder how expensive calls are versus just running a loop. I would have expected the call to be more expensive than a loop, but maybe not. But I haven't seen anything that tells me that one way or the other. Okay, but anyway, find min, base case, one of those followed by a bunch of those, and so we're going to find x and then find min y plus. Oh, this is interesting. Oh, because it's calling itself. It's calling itself with right. All of y. Well, no, hang on. Comma plus. So is that? Oh, okay. So that's going to call that this first thing. $y. That's going to be x in the next iteration, and then the comma plus is going to be y. Interesting. That's kind of a fun syntax there, because honestly it means something different here. Oh, it's matching though. No, because here $bracket $y bracket comma plus is a single parameter. Here $bracket $y bracket comma plus is two parameters. Because otherwise this recursion won't work, right? Because find min will call itself, but it needs to be calling itself with an x and at least one y. What's interesting is that we don't have to have an end condition for this loop, because it's just going to stop. Is it going to stop? How does it know to stop? How does it know not? How did it know not to throw an exception, or whatever it is, the equivalent in here, when it ran out of y's? Will match one or more expressions. Also note the semicolon is optional in the last case. Yeah, I don't know. All right. So there's something magic going on here, because it's able to, without me having to do any test, it's able to figure out that it shouldn't call min again, or find min again. Well, actually min again. So it's going to attempt to call find min, but there won't be a y, because it'll be empty, so it won't match. And so does that mean it doesn't call it? Oh, actually, yeah, maybe, because here, look, find min 1, it stops. It just says, oh, yeah, there's nothing else. I'm just going to not do any more. So it's just going to call min of x and nothing, which, let me see, what is the min of x and nothing? 1. Really? So nothing is different than 0, I guess, in this case. Interesting. Interesting. So y is an expression, so it's evaluating y. But if there's nothing to evaluate, then it does nothing. Again, fascinating. That's some tricky little syntax going on here. Huh. Alright, well, I have to remember that one. Because yeah, like every language I could think of, well, I mean, JavaScript would fall over because it would just say undefined if you did this. But you'd have to write an if statement. You go, if, and C# would definitely fall over with this kind of thing because it would say, oh, you're passing me, I'm expecting an array of something or a single value of something plus an array of something, and you're not passing me either of those things, so I'm dying right here. So we definitely have to have an if statement. But here we don't. Interesting. Okay. Gotta file that one away. Dry, don't repeat yourself. Macros, yeah, whatever. An example that implements the tests and tests the plus equals, star equals, and minus equals operators on vec. Assert equal length. Oh, token tree. I knew we didn't have to look it up. Used for operators and tokens. So expression, ident. Okay, and so what are we doing here? So ident is plus equals, star equals, minus equals. Ooh, no quotes. That's cool. That's actually kind of fun. That one, look at that. You can actually write parts of the language kind of not in context, and it's all good. Expression is add and add a sign, sure, and then the last thing is tt is add. Okay, so what have we got going on here? Assert equal length. The TT token tree is used for the operators. Okay, fine. Whatever. Token. All right, and then assert. The lengths are the same. Oh, yeah, assert, which is a macro. The lengths are the same, and then amend other or. We're going to stringify func and stringify opt and say, yeah, they don't match. Okay, sure. So yeah, if this is false, then we're going to dump out this assertion. Okay, I get it. And the operator. Okay, what are we doing here? Oh, right, this. Oh my goodness, this bit here. Well, this is going to strain my brain trying to remember what all this means. Oh. Yeah, I don't remember. I don't remember. I'm not going to look it up. But maybe we can figure it out from the context. Okay, so what are we doing here? So we're iterating over the zip. I don't remember what that does. And then we're saying, yeah, oh, we're doing something with method x and y. So we're applying the method to x and y. Okay, let's see. So, and here, op, so that's the method. Third parameter is fourth parameter. So add, ident, add. So we're calling add xy. And we are doing this in the TT, which we don't use anywhere. Function vector ys xs ys whatever ts, yeah. So TT is just for decoration, just to prove we could do it, because it doesn't appear to be used. Is it used here? There's TT, but this is op define. Oh, unless assert equal length. Oh, there. Sorry, assert equal length. Op, right? Op. Okay, so we're doing this assert equal length and then iterating over them and doing some kind of work. Okay. Okay, we're iterator, test, whatever, func. Okay, repeat x, take, collect. Okay, we got XYZ. We're going to, oh boy, test, add assign, multisign. Okay. Ay. Huh. This is getting dense. All right. Let's see if we can figure this out. Okay. So we have this assert equal length, which what it's doing is it's saying, well, if they're the same, fine, but if they're not the same, then dump out this string. Then we got this macro rule up, which is taking the 4 parameters, including TT, and is then creating a function which has some mapping that I can't remember what this means, xs and ys, and then we're going to pass xs and ys, which are vectors, one of which is mutable. The xs is mutable and the ys is not. And then we're going to say, hey, they're the same. So if they're not the same, then I guess the assert fails and we can just stop right there. If the assert succeeds, then we're going to do the rest, I assume. This is how it's going to work. And then we'll do this, and we're then iterating over x and y. So I guess the zip is iterating over x and y, and then we're going to get both x and y and apply method and update x with that. Now we've called op 3 times. Not sure what this is doing because okay, no, I know what we're doing, because we are implementing, the name is function, so we're creating this function. Oh, okay, so we've created this function called add assign and a mul assign and a sub assign, and then we're passing this information in addition to. Okay, so that we've created these 3 things. Now down here we're creating, now this is where I got lost, because now we're creating another macro here called test, which creates another function which creates 10 element oh, but we pass it in the ident, the function name, And so we're going to apply another function. So we're going to say, hey, super func do that. So we're executing, so this line is executing one of these three, this code, one of these three, because we're going to pass in add a sign, and then we'll pass in add a sign as the func, which will then say, oh yeah, well, but then here's the weird part, is that we named this test. Oh, the test is named that. And then we're going to call that with the two arrays, and then we're going to say assert equals x and z. Okay, so we're going to iterate, do some operation. Well, how did we get, where'd z come from? Pete z star. Oh, because we're going x, y, z. And it's like 1, 2, 3. So it would be 1 plus 2 equals 3. 2 plus 3, or 2 times 3 equals 6. 3 minus 2 equals 1. Okay, so we're going to do it 10 times, but it's the same number 10 times. Gotcha. Okay. Wow. Wow. All right, so this is test, running tests too. Huh. Wow, this is pretty deep in the weeds. Man, I don't think I could write this code right now. Some of it maybe, but I really have to struggle and look things up. Especially, I think, you know what, I could probably manage most of it. I kind of got lost here with the test, but this is the first time we've seen, I think this is the first time we've seen testing. Yeah, we haven't talked about testing before, so this is just throwing me some new stuff here. Testing is in 21. So we've not talked about testing before. So that's kind of fun, that we're just going to throw that in. Thanks, guys. All right. But yeah, I got. But yeah, this part here, this abstract stuff here, I don't remember the plus sign, what it means. I think copy. I think this is what you put in, so we can have it. I don't know. It's something to do with borrowing and ownership or something or other. Yipes. Okay. Anyway, that's enough. We'll move on. Domain-specific languages, many language, but in Rust is valid because macro system expands to normal constructs, but it looks like a small language. Suppose you wanted to create a little calculator API. I would like to supply an expression and have the output printed to a console. Eval 1 plus 2, 3 plus 4. Eval, calculate. Eval. Expression, E. So we're just going to stringify, right? And then execute the expression. Okay, but this is not a string. It's an actual thing. Okay. So that's the difference, right? What I was saying before. If you could put that in quotes as a string and have somebody user type it in on their keyboard and input it, that's one thing. But this, I mean, you can't type that in because there's no quotes around it. It doesn't come from. But so you'd want to convert it into that from a string, which I don't think. I think that's what I was saying before. I don't think we could do. Okay, cool. I won't be doing that for a while. Arbitrary arguments. I think we've already played with this comma plus thing. But have you got anything more to say about it? Okay, whatever. Error handling. All right, how are we doing? I started late. Let's see how far we can get in error handling today. Error handling is a process of handling the possibility of failure. Although, yeah, let's stop. I'm going to stop, and then I'm going to carry on another time with this. Make the videos a little easier to digest. All right. See you next time.